Hello there people, this is Christian. Welcome back to my computer and Fusion 60. I'll pop up the next one. And this Hirth joint or interlocking coupling. The interesting part of course is that these two parts are identical. It's not self-interlocking, but it's the same part. And it has some interesting features. It pops up now and then in forum and places, and I've seen a couple different videos on how to make it. So this is my video. And I will avoid using trigonometry. I will use geometry. That's also a type of math, but I would like to avoid equations. We're going to sketch out things we need. Let's first just have a short look at the video. This is from Schneeberger that makes grinding machines and other stuff. This is how one of these are manufactured in metal. So it's grind at the top or landing, flat part of it, and then it switches over to a different grind wheel which has an angled face. You can see here this is an angle cutting tool, and that's going to mimic. You can see if it goes up and down. If you look at the material, it moves slightly back and forth. It follows a line that goes to the center and it spins over and do the next one. I'm going to pause it here. Here's the reason why you don't see it that often. The cycle time is 53 minutes. It takes a special machine, so these parts get expensive. But with 3D printing, we can easily make things like this. And we have a little more of liberty choosing dimensions and stuff, and we need to adapt it for 3D printing, of course. So you can see here are two parts. In this case, I made a fillet in the bottom and a chamfer up here. I'll do slightly different workflow, but I will suppress these two just to show you. I will start by doing this shape. Everything with sharp corners, and we can check that the geometry correct. So I have a new design here. It's saved. I will start by creating a new component because I would most probably insert this into some other design. So H joint, whatever you want to call it, interlocking coupling, open up in the browser. I need some basic parameters, and I need like an outer diameter. Let's make that 50. I'm going to add one more. We need an inside diameter. Let's make that 20. We need to decide the number of grooves or teeth, or what you want to call them. Grooves count. This need to be a no unit. Let's make 20. And for the basic shape, we need to decide the angle between the angle of the groove. Let's call it groove angle. That of course gonna be degrees. Normally those are 60 or 90. And hit OK, so we have our basic information. Let's look at my previous model. So just to explain, this is a flat face. We can check that by doing right click on a face and see. We can do where are you? Oh, there you are. Sorry, I jumped a minute. I can create a sketch. You can only create sketches on flat planes. And the dimension we're giving is, of course, that these two are exactly one. In this case, 90 degrees. Going to move that back. So let's get back to my design here. We have set up parameters. Let's start with a sketch. This is going to be from the top. We're going to have two circles. That's going to be our outer diameter. And we're going to do an inside diameter like that. These are slightly in the way, like that. Next thing I'm going to sketch, I'm going to do some lines. It's going to be construction lines. I'll make them something like this. Make a line in between them. Tell Fusion that lines needs to be horizontal or horizontal vertical constraint. Going to do some more lines. I'm going to find the midpoint here. Going to go down, straight down, perpendicular constraint to the horizontal line, over to here, and over to here. Of course, this horizontal vertical line here locks that these become the same length, or they become symmetric. So, step one, I want a dimension between these two lines. These two lines represent the center of the groove face. Let's jump over to here. So the lines I'm making is, is the line that's run through the center of the face here, and easy to point here. The center of the face here, and the second line is center of the face here. And the angle we're given a dimension is the distance from here to here, or from here to here. So the distance between the center face here should be half. I hope you are with me. D for dimension. These two lines Sorry, not that one. Let's undo that one. Dimension from here to here, like that. So of course we have 360 degrees. We divide that with our group count. And as we said, we need half of that, so we divide it by 2. So now we have that. This shape here is the shape of our cutting tool. So this dimension between the angle here, that needs to be the angle of our desired groove. Groove angle, like that. I'm gonna finish sketch, open up our sketch browser, click. If you hit F2, you can immediately change the name of the sketch. So we're gonna call that top view, so we know what we're doing. Going to create a second sketch perpendicular to the first one, and I'm going to select the plane that goes through my little construction lines here so I can use them. Zoom in, slightly rotate over, hit P for project, and I want to project in this line here. I'm going to hit OK. That's all I need. I'm going to turn off my first sketch and do a look at, so it rotates over to correct orientation. This line here, I'm going to switch that over to construction line so it doesn't confuse me. I'm going to hit C for circle. Also construction. This is just construction. I want to avoid profiles because you can by mistake click on the wrong profiles. If I run everything with construction lines or optional, I can turn off profiles in the sketch. I will not be able to select the profiles. Circle, nothing strange. Constrained with this line we projected. Rectangle, and I'm going to switch that over to 3-point rectangle so that I can angle the rectangle slightly like that. Coincident constraint from here to here. So we're going to constrain the diagonal of this rectangle to the origin point and the center point of a circle. So that over here. Now with 2 choices, we could use a tangent constraint, but I will keep on doing with coincident. If I take coincident between this point and the circle, that means this line here is tangent to the circle because it's perpendicular to the radius of the circle. So this down here, this is the path for the cutting tool. So I'm going to finish sketch. Going to click on the sketch, hit F2 and call it side view. Like that. And it gets so small. So now we want to sketch our cutting profile. And of course, our cutting profile should follow this line here. So I want to create it on this angle line here. So we need a construction plane. Plane at the angle. Avoid selecting the axis. I'm going to zoom in a bit so it becomes larger. So we select this line. It's orientated perpendicular. So I want to change that to 90 degrees. Going to hit OK. We're going to create a sketch on a new beautiful plane. This sometimes rotates things in a bit of strange orientation. You can see Z-axis is suddenly to the right. So I like to do to orientate myself, hit the home button. You can even turn on our first sketch so we can see things a bit easier. So what I want here, let's turn on the top view. So high sketch like that. What I want here, I want to project in the point down here. Origin point happens to end up in the middle of the line. That's not interesting. I want to find out where this point is. Gonna hit OK. Do the line tool, not construction lines. Now I'm going to do normal lines to start with. We're going to sketch a rectangle, try and get where are the perpendicular constraint. Oh, that popped up. Horizontal vertical constraint. I could add it by hand later, but I'm going to do it like this, down to here. I'm going to make one more line. I'm going to make a construction line from the point we projected up to the midpoint of here and use a horizontal vertical constraint. That means that we get a symmetry in the sketch. Dimension, D on the keyboard. This here is going to be our angle of our cutter tool. So we're going to do the angle, groove angle. And what I would do now, you can see in the video, the grinder tool was quite small, but I will simply super oversize things. I will make this the outer diameter of our part. And I need one more thing. This can be done differently. This is how much we need to extrude the cylinder we're going to do this cutting from. For simplicity, I'm going to hit S on the keyboard and do point. And find the midpoint of this construction line. Put a point there so I can do extrude to object using that point. Gonna finish. Gonna hide. Let's rename that to F2. Cut. Profile. Groove. Like that. So we got most things going on. We're going to hide the side view for now and turn our first top view on. And we're going to start doing some extrude. E on the keyboard, select the desired profile. And we're going to do these two sides. The first one, distance to object. I'm going to select the midpoint here. This gives me enough material for this cutting tool to cut away from. And the second distance, I can select basically whatever I want. I need to make sure that it's at least enough material for this. This is going to cut a triangle down like this. So I was going to do 15 for now. We can change that later. Going to hit OK. E for extrude, select our cut profile. Now it happens you can see the arrow is pointing backwards. So I know I need to do this. I'm going to delete the distance like that. It's going to be minus, and just to overdo things again, I'm going to use the outer diameter. So you see we get really cutting through everything. We don't miss anything. Cut. I'm going to hit OK. I'm going to hit S on the keyboard and start typing circular because I want to do a circular pattern. What do I want to pattern? I want to pattern features, our latest cut here. And what axis? I can select the center axis or simply select the outside of the cylinder. And I want to make sure that these are just what you normally see. The quantity is totally off, of course, so we're going to change that to the count. And we get a bunch of cuts. And we have computer type adjust, so we get clean cuts, everything cuts away. Adjust means it repeatedly does the same extrude. It's a bit more computer, it needs more computer power, but it gets the cleanest model in this case. I'm gonna hit OK. That is for another video explaining the different compute types. So we have now made, let's hide our sketches. We have now made our basic Hirth joint. So for now, I'm simply going to save this so I don't lose things. And turn on our first sketch. So let's do some checking. Is this will interlock with itself? Yes, once again, circular pattern. In this case, I'm going to make it of bodies. Bodies, select the body we just created, select the axis, and we can of course select the center axis of a face. If we rotate one copy this 180 degrees around this axis, they should, too many copies, change it to 2, hit OK. We now have 2 bodies. Hide the sketch for now. This is just to check that I dimension correctly. Gonna have a look. We drag down, we can see the tooth running here like that. Gonna cancel that. To see if I can merge these two into the cylinder. That means that all faces are touching. Select both, do a join operation, and we end up with one single body. There's 2 bodies. Let's move back in the trial line. We can see we have 2 bodies. And if we do this, it's merged into one body. Let's do a section analysis. And there are no remains from a goose, so they line up perfectly. I'm going to delete this and delete the circular. So I'm back to having, recalculate model. Here we are. We are back to having one single body within this joint. Going to jump up to root level and do an S for circular pattern. In this case, I'm going to make it of components. Select this component once again, the same axis. Let's find it. Where are you? There. 2. Yes. So the difference now, hide the sketch, is that I have made 2 components. Now I need to combine it. We know we can combine them into one cylinder. So they are touching in tangent surfaces everywhere, but we want to check that they are not interfering. So by creating 2 components, we can use inspect interference, select our 2 components and do compute no interference detected. So these 2 components are not overlapping. They are touching, but they are not overlapping. So let's delete this. So we are back to having one Hirth joint. Just make that component active. Yeah, that looks nice. So let's say now we like to add the top landing and the bottom fillet. So I'm going to add one more parameter here. This is a bit up to yourself. If you're going to 3D print this, you could simply just fill at the top and circular pattern that. Or we can do it like I'm doing now. This is a bit of overwork. Of course, you want to avoid this sharp edge up here if you're 3D printing. That's going to be a mess, so you want to cut that down a bit. Let's start by adding a parameter. Groove fillet, and that's going to be radius. Let's make that 0.2. It's going to be quite small. Oh, I forgot to do one thing. Let's try our model before we add more shit to it. Sorry. Let's change the number of teeth. Can we change it to 30 teeth? We can. Can we shake it back to 20 again? Yes, we can. Can we make it more steep tooth? If we make a smaller angle, the teeth gonna get, or the grooves gonna get higher and more sharp. And of course, we can make them lower. We cannot make them 180 degrees because then the model will fail. And we can change the inside diameter to 10. We can make it down to, whoops, sorry. That was wrong. 20. And of course, we can make a lower number. It makes a quite interesting system. So far, our model is parametric. Gonna hit OK. We're gonna move back before. This is dependent if you're gonna do construction stuff. You might want to do the fillet in its own fillet, in its own circular pattern, if you want to add, remove it through configurations. If you do multiple things within the same circular pattern, you need, in configuration, if you want to suppress something, you will suppress everything inside the circular pattern. That's another discussion. But I think it's easily this. This edge will always exist. So we're gonna hit F on the keyboard, select the edge, and that's going to be our fillet radius, like that. Going to move up to my circular pattern, edit the circular pattern, and objects, we're going to add the fillet, hold down Control and select the fillet to, still adjust, hit OK, and we now have a fillet at the bottom. Of course, the top of this mountain or peak is now going to hit the bottom, so we're going to solve that. But before we do that, we're going to check, does our parameters work? We get fillet everywhere. Can we do to turn 30? Yes. 20. We can change the angle. We can change the angle back. Good. Our model is still not broken, so I'm going to do a save now, just to be careful. We're going to turn on the side view. We're going to look from the right, so we're looking at the sketch, hide the body, create a new sketch on the same plane as this. I will hit P for project and project in a couple of things. If I turn on the body, you can see that this point is well beyond the outside of the cylinder, so I'm going to use that point. And I want this line here. This is a line of a bottom groove, but symmetrically to this, you have a peak at the top here. So I'm going to project in that so we can use that. I'm going to hide that sketch, turn that into construction geometry, and start doing some fun sketching. I'm going to do some lines. So the tool, I want to revolve a cool tool that I can cut off the top landings of all the teeth. So that tool needs to look something like this. So let's do some constraints. Coincident, if I make this line coincident to the point here, that is well beyond the outside of the cylindric body, so I get a full cut. This here, of course, needs to be to the center point here, and we need to do some dimensions later. The thing is, I want this to be the opposite angle of this one. There are a couple of different ways. We could sketch a second line, or we can do some symmetry constraints. This is one way of doing it. We're going to do a line, hit L on the keyboard, construction line from here up to here. And then I need to make a small break. I'm going to break this line down here. I'm going to use the break tool. This is going to break this. So now we have two lines, one up here and one small down here. Going to make one more line, hit L on the keyboard, construction line, and going to find the midpoint of this, move over to the midpoint here, until fusion, that needs to be horizontal. Hit escape. So what we made now, it happens to jump up above, so I'm going to drag this down now. You can see this now stays like the opposite direction, symmetric turn around. And we need to hit D for dimension. This point here is where the peak is done on the body. We can do a slice to. This point here is where this peak up here is pointing, so we can do dimension. Let's hide the body once again. Turn on off the slice. Don't forget to turn off slice if you do that in sketches. From this line to this point here. And this is going to be how far down we do the cut, the revolving cut. For simplicity, I will use the fillet radius we decided earlier. Gonna hit enter. So we have made our tool. Oh, we're missing one. See, we're not fully constrained. So just for simplicity, I'm simply going to do it OD once again. So it's well over dimension. We could also take this line here and turn that into center line. That helps with revolve command. Should select that line now. S on the keyboard, you can see I already set up my tools here. S on the design shortcuts, you find it with S on the keyboard. I try to set up things here and it basically selects everything I want. It understands I have a center axis and I have a profile. But it creates new body. So let's turn on our original body and the operation will turn over to cut. And I'll hit OK. So this is our landing. Oh, sorry. Cut landing per file. Name things so you know what they are. We're gonna hide that one. So we might want to check that we do not have interference. So we're gonna do an S and a circular pattern. In this case of our, yeah, we can do it for components just for fun. And we select this. The axis is gonna be this one here. We're gonna make 2 of them. We're gonna hide the sketch and have a look. So we can have a look here. We have a fillet and we can see that the cut down is a bit deeper. We can try and change this to 0.5. And you can see we have enough room. Let's switch over to hidden lines, Control 5. We got this nice Hirth joint to play around with. I can hide the second one. So this is how I would model it. How we want to make these fillets of a top line is up to you. If you want to do it, you can make sharp edges, but they will most probably snap quite early when you use them. And yeah, do want to end this more? No, that's all I want to say about this. So I hope you enjoy this, and we'll say take care, see you around, and goodbye.